Okay, time to get started. Sorry for the delay. So we need to simplify this. This is a square root. So if we break up the 27, this turns into a 9 and a 3, and this breaks up into a 3 and a 3. So that's going to stay. X squared, since this is a square root, we want this number right here to be a multiple of 2. So this y right here, I'm going to change this to y to the 6th times y. So therefore, since I have a pair of 3's, the 3's will come out. The square root of x squared is x, and the square root of y to the 6th would be y to the 3rd. And since this 3 and this y are left over, they go back under the root. So that's our final answer for that one. For this one, 80. 80 breaks up into 10 and 8, which breaks up into 5 and 2. That would be 2 and 4, or also 2 and 2. And the m to the 4th is going to stay, but the n to the 5th is going to become an n to the 4th times n. So we got 2 times 2 on the outside, which makes a 4. The square root of n squared would be m to the 4th would be m squared. The square root of n to the 4th is n squared. And I want to be left with a 5 and an n going back under the root. Done. Same thing here. The 16, or the 48, I'm going to break up into a 16 times 3. X squared is going to be an x squared x. So the square root of 16 is 4 and 4. And since that's a pair, I don't really need to go any further. So I'm going to pull out a 4. The square root of x squared is x. The square root of y to the 6 is y to the 3rd. And then all the stuff that was here to begin with, we've got to put it back in. So it's a 5x squared. And anything that goes back under the root, like the 3 and the x, go back under the root. 4 times 5 is 20. X times x squared is x to the 3rd. And that's y to the 3rd root 3x. Final answer. For this one, since this is a cube root, this one's going to be a little different. I'm looking for multiples of 3. So therefore, when I break this up into an 8 times 3, and that's a 4 times 2, and a 2 times 2, since there's a set of 3 2's, that's what's going to come out in front. Since this is a cube root, that's also a 1/3 exponent, so I'm looking for exponents that are divisible by 3. M to the 6th is divisible by 3, but n to the 5th is not. That's going to turn into n to the 3rd times n squared. So the cube root of m to the 6th would be m squared, because 6 divided by 3 is 2. And then n cubed to the 1/3 power makes that just an n. And we're going to be left over with a 3 and an n squared. Make that a cube root. For this, we're going to distribute this into each of the exponents. So this is 64 to the negative 1/3 power. And then x to the negative 3 power. So 64 to the negative 1/3 power. That would be, let's break that up into 16 and 4, and that's going to be 4 and 4. So there's our group of 3. But because it's a negative exponent, it needs to go underneath the fraction, so that's going to be a 1/4. And since this is an exponent, the x right here, this is going to go underneath as well and be an x to the 3rd. Remember, when the exponent's negative, it goes across the fraction bar. 3 times 8, that is 24. X to the 1/2 times x to the 3/4. When that happens, you need to add the exponents. So this is 1/2 plus 3/4. And I'm going to multiply the left side, top and bottom, by 2 to make this 2/4 plus 3/4, which is equal to 5/4. So our final answer is 24x to the 5/4 power. No. Okay. So that's the first 6 problems. Next few problems are going to look like this. This is a 4th root. So 8, if I break it up, or actually, since these are both 4th roots, I can combine whatever's underneath the exponent. So this would be the 4th root of 8 times 4 is 32. X cubed times x to the 6 makes that x to the 9th. And then y to the 3rd times y is y to the 4th. So the 4th root of 32, if I break this up, this would be an 8 and a 4. That's 2 and 2. 2 and 4. 2 and 2. So there's 4 2's here. X to the 9th, I'm going to break up into x to the 8th times x because I want it to be a multiple of 8, or a multiple of 4, excuse me. Y to the 4th. So therefore, this is going to be equal to 2. The 4th root, 8 divided by 4 is 2, so this is x to the 2nd power. 4 divided by 4 is 1, so that's y to the 1st power. And I'm still going to be left with that 2 and the x from the original problem. Again, let's multiply everything to start. I mean, we don't really have to. Do we really? Let's see, 15 times 12, 150. Yeah. So, I'm going to try to simplify these beforehand. So, 3 times 7 times m, that's going to be a 21m. The square root of 12, that's going to turn into the square root of 4 times 3 times m squared m. So the square root of 4 is 2, so times 2. Can't take the square root of 3. Square root of m squared is m. Can't take the square root of that m, so those are going to go back under the roots. So times root 3m. And then when I simplify this guy over here, 15 is 5 times 3. And the m squared is going to pull out another m. So this is times the root of 5 times 3 with an m on the outside. So I'm going to have on the outside 21 times 2, that's a 42. M times m makes that m cubed. And since there's a root 3 here and a root 3 here, I can actually pull that 3 out, and I'm going to be left with 5 times m, which is 5m. So our final answer is 126 m to the 3rd power root 5m. We need to simplify both of these since we're subtracting. Hopefully we get like terms. 75 breaks up into 25 and 3. And then n squared, or n to the 5th, could be n to the 4th times n. So the square root of 25 is 5, so that's 4 times 5 times m. And then the square root of n to the 4th power is n squared. And all I'm left with is a 3, an m, and an n. So 3mn goes underneath. Gotta simplify this guy. So that's minus 2 times n squared. 48 breaks up into 16 and 3. So the square root of 16 is 4. M to the 3rd, 3 divided by 2 is 1. So that's m to the 1st power with an m left over. I'll write that up here so you guys can see that. And the n's going to be left over. So that's going to be left, that's going to be left, and that 3 is left. So root 3mn. So this is 20 mn squared root 3mn minus 8 mn squared root 3mn. And if you take a look, all of these variables are exactly the same, so I could subtract 20 minus 8 to make this 12 mn squared root 3m for our final answer. Same thing for 10. This is a cube root problem. So if I break this up into cube roots, I'm going to have x times the cube root of 8 times 5 times x to the third power times x, because remember I want that to be a multiple of 3, plus 4 times the cube root of, that's going to be 125 times 5, x to the 6th power times x. So I have on the outside x, the cube root of 8 is equal to 2. The cube root, can't take the cube root of 5. Cube root of x cubed is just x. Can't take the cube root of x, so I'm left with 5x underneath. So I got 4. The cube root of 125 is 5. Can't take the cube root of 5. Cube root of x to the 6th power is x to the 2nd, because 6 divided by 3 is 2. And that x is left over with a root 5x. So this is 2x squared cube root 5x plus 20 x squared root 5x. All in all, for a grand total of 22x squared cube root 5x. All right. Next. Graphing. So with graphing, you need to follow a 1, 3, 5 pattern with the x values. So these are your runs. And the number that comes in front of the root, that is your rise. So you're going to have a rise of 2. So we usually start right here at the origin, right here. But because we have a shift of right 3, up 1, we need to go right 1, 2, 3, up 1, and that's going to be our starting point right there. So we follow this pattern of rise 2, up 1. So up 2 over 1, put your dot down. Next we have rise 2 over 3, rise 2 over 1, 2, 3. Put your dot down. So you're going to take it and move it up. There's your graph. So your domain is going to be all the x values that you could have. So the domain is going to be all real numbers greater than or equal to 3. You could also write that as 3 to infinity in interval notation. Oops. The range is all the possible y values, and that first point was at 1, so this is going to be all real numbers greater than or equal to 1, or in interval notation it would be from 1 to infinity, like so. To find the x and y intercepts, you could just look at the graph and tell they don't cross x and y anywhere, so you could put none. Here's how you would check if you needed to check yourself. Actually, I'm going to do that in the next one, and I don't want to waste time. Average rate of change, this is x to the first power, sorry, x1, x2. So we need to figure out what y1 and y2 are. So we're going to plug this number in to find y1, this number in to find y2. So it's 2 times the square root of 3 minus 3 plus 1. That's 2 times the square root of 0 plus 1. 2 times root 0 is 0 plus 1 for 1. That is our y1 term. To find y2, we're plugging 12 into the function. 2 times the square root of 12 minus 3 plus 1. So that's going to be 2 times the square root of 9 plus 1. Or 2 times 3 plus 1, which is 7. And that's going to be our y2. So to find the average rate of change, we're going to go y2 minus y1 all over x2 minus x1. y2 is equal to 7. y1 was 1. x2 was 12. x1 was 3. For a grand total of 6 over 9, which is 2/3. Next problem. Okay. Again, this number in front is our rise. Our run is going to be 1, 3, 5. So we have to start at -4, -3. -1, 2, 3, 4, -1, 2, 3. So we're going to rise 3, 1, 2, 3 over 1. Rise 3, 1, 2, 3 over 1, 2, 3. And rise 3 over 1, 2, 3, 4, 5. So this graph is a big looping graph that goes like that. So our domain is all of our possible x values. So domain is all real numbers greater than or equal to -4, or from -4 to infinity. The range is going to be all real numbers greater than or equal to -3, our y value, or it'll go from -3 to positive infinity. For the x and y intercepts, you can see that it crosses the x-axis at -3. So -3, 0 for the x-intercept. For the y-intercept, you could tell that it crosses the y-axis at 0, 3. So where g of x is greater than 0, that's everywhere up here, where we're above the axis. And that is where we are greater than our x-intercept. So that is going to be from -3 to infinity, because it goes on forever. And we need to figure out where we are less than 0, which means we are below the axis, and that's everywhere down here. So that would be from down here at -4 until we hit the x-axis of -3. If you needed to find the x and y intercepts without a nice graph, what we could do is we could plug stuff in to this function. So to find the y-intercept, you got to plug 0 into x. So it would be y equals 3 times the square root of 0 plus 4 minus 3. That would be 3 times root 4 minus 3. And that would come out to 3. To find the x-intercept, you would need to plug 0 into y and solve for x. 0 equals 3 root x plus 4 minus 3. Add 3 to both sides to get 3 equals 3 root x plus 4. Divide both sides by 3. 1 equals the square root of x plus 4. Square both sides. 1 equals x plus 4. or x is equal to negative 3. That's the long way to do it. Easy way is look at the graph. Okay, for h, domain and range. This is a cubic function. Sorry about that. This is a cubic function. To do the cubic function, a cubic function has a weird pattern. It has a run of 8. Sorry. It's 1, 7, or 0, 1, 7. And again, the rise is whatever's here. So first let's do our shift. Our shift is right 1 up 4. So right 1 up 1, 2, 3, 4. There's our dot. So we're going to rise 1, run 1, rise 1, go 1, 2, 3, 4, 5, 6, 7. It's going to go off the grid. And from our vertex, we need to go the opposite direction, down 1, left 1. Down 1, left 1, 2, 3, 4, 5, 6, 7. No, baby, you can't have this. It's my kitty. Hi, kitty. Sorry, I totally spaced out right now. I needed to eat something. I have sugar. Okay, so there's our graph. Domain and range. So for domain and range, it's actually both of them are all real numbers. Because it goes up forever, it goes down forever, it goes left forever, it goes right forever. Our x and y intercepts. The y-intercept's easy. You can tell that it crosses at 0, 3. But we need to solve for the x-intercept because it's going to be way over here where it crosses. So that's 0 equals the cube root of x minus 1 plus 4. We need to subtract 4 from both sides. And we get negative 4 is equal to the cube root of x minus 1. Cube both sides. Negative 4 cubed is negative 64, which equals x minus 1. And then add 1 to both sides to get negative 63. So the x-intercept is at negative 63, way the heck off the graph, comma 0. And the average rate of change is going to go from here to here. This is x1, this is x2. So we need to plug them in. So this is the cube root of 1 minus 1 plus 4. That's the cube root of 0 plus 4, which is just going to be 4. So that's our y1. Got to plug in 9. So this is the cube root of 9 minus 1 plus 4. That's the cube root of 8 plus 4, which is 2 plus 4, which equals 6. So that's our y2. Plug them into the rate of change formula, which is just like this on your screen. y2 is 6, y1 is 4, x2 is 9, x1 is 1, for a grand total of 2 over 8, which reduces to 1/4. That is our average rate of change. Okay, domain and range. So we got, let's graph this first. We got left 7, up 6. Left 1, 2, 3, 4, 5, 6, 7. Up 1, 2, 3, 4, 5, 6. Right here's where we start. And this is a -3, so we're still following the 1, 3, 5 pattern for the run, but we're going to go down 1, 2, 3, right 1. Down 1, 2, 3, right 3. Down 1, 2, 3, right 1, 2, 3, 4, 5. There we go. So domain and range. Domain is going to be all numbers greater than our x value. So all real numbers greater than -7, greater than or equal to. You would write that as from -7 to infinity. And our range is going to be all real numbers less than or equal to 6. It's less than because our function is going downward. So it would be from -infinity to +6. Okay. Our x-intercept is really nice. We just got to plug in our x, or look at it on the graph. The graph is at -3, 0. Our y-intercept isn't so nice, so we're going to have to plug it in. -3 times the square root of 0 plus 7 plus 6. So that's -3 root 7 plus 6 is our y value. So 0, comma, that is our y-intercept. Remember, it's greater than 0 everywhere over here, which starts at the x-intercept. So that would be from -7 to -3. And it is less than 0 everywhere afterwards over here. And that would be from -3 to infinity, because it's going to keep going down no matter what. Solve for x algebraically. So we want to get the root by itself. Our first step to get the root by itself is to subtract 17 on both sides. So -4 times the square root of x minus 8 equals -36. Square root, or divide both sides by -4 is going to be the square root of x minus 8 equals 9. Square both sides, and you get x minus 1 equals 81. Add both sides to 1, and we get x is equal to 82. So remember, we got to plug it back in just to check for extraneous solutions. So 17 minus 4 times the square root of 82 minus 8. I didn't add 8. My bad. Wait. I added 1 instead of 8. That was weird. So I should add 8 to both sides. And that should come out to 89. So plug 89 into the function. Check to make sure it works. 17 minus 4 times 9 is equal to 36. And that all comes out to -19. So it checks out. For 16, again, we got to get the root by itself. Subtract 18 on both sides. 3 root x plus 4 is equal to 15. Divide both sides by 3. And square root of x plus 4 is equal to 5. Square both sides, and we get x plus 4 is equal to 25. Subtract 4 on both sides to get x equals 21. Double check your answer. 3 times the square root of 21 plus 4 plus 18. That's 3 times the square root of 25, which is 5 plus 18. So 15 plus 18 equals 33. Checks out just fine. Okay, so we're going to subtract 4 from both sides, because remember, we have to get the root by itself. So this is the square root of x minus 2 equals x minus 4. We need to square both sides, so put that in parentheses and square it. So this is x minus 2 equals x squared minus 8x plus 16. You would FOIL this out to get this. We're going to add 2 and subtract x from both sides to make sure that's equal to 0. So we get 0 equals x squared minus 9x plus 18, which comes out to x minus 3, x minus 6 equals 0 for answers of 3, 6. Plug it back in to check. So 3 minus 2, square root of 3 minus 2, plus 4 is equal to 3. That's the square root of 1 plus 4 is equal to 3. That does not work. Let's try 6 now. Square root of 6 minus 2 plus 4 equals 6. Square root of 4 plus 4 equals 6. And that checks out fine. So 6 is our only answer. 3 was extraneous. Again, get the root by itself. Square root of 5 minus x equals x plus 7. Square both sides. So we get 5 minus x equals x squared plus 14x plus 49. Subtract 5, add x. Subtract 5, add x. So x squared plus 15x plus 44 is equal to 0. That factors into x plus 11, x plus 4. And we get x equals negative 11, negative 4. Don't forget to plug it back in to check your answer. You're going to get square root of 5 minus negative 11 minus negative 11 equals 7. And that's going to be the square root of 16 plus 11 equals 7. That doesn't work. Cat! Come here, cat. Come say hi to my students. Come on. Don't be so shy. Come on, say hi. You're famous. That's my cat. Not the same one from earlier. Okay. To simplify, we're going to multiply by root 2y, top and bottom. So this will be 4 root 2y. And the roots will cancel, and this will just be a 2y. And 4 divided by 2 is 2. So this is 2 root 2y over y. Over here, this is going to be times. We need to get the root by itself, so we're going to multiply by what's called the conjugate. Cat, I swear. Shh. I am not doing anything to you. She's very needy. So times the square root of 5 plus 2. We're going to do that top and bottom. So on the top, we're going to distribute the 6. So that's going to be 6 root 5 plus 12 all over. We need to FOIL this. Root 5 times root 5 is 5. Root 5 times 2 is going to be plus 2 root 5. Negative 2 times root 5 is negative 2 root 5. And negative 2 times 2 is negative 4. So our final answer is 6 root 5 plus 12 all over. These guys cancel. 5 minus 4 is 1. So that's basically our answer there. So that's going to do it for Unit 6. I'm going to be working on Unit 7 while this one uploads. Any questions, send me an email.